In this paper, we present PoseCoach, a tool for providing intuitive feedback on running poses for amateur runners. Existing video-based coaching systems may require a human coach to watch the video playback and manually annotate the feedback on top of the video. Some other systems show pose differences between a novice and an expert by overlaying the expert's pose onto the novice's pose. The pose differences are highlighted by visual markers augmented onto the video. However, when observing a 3D attribute, an angle for example, its appearance in 2D is largely different when observed from different viewpoints. Videos thus confine the observation of 3D attributes and cause ambiguity in the augmented markers. Suppose an amateur runner would like to compare his running poses with a professional runner. How can he best analyze and perceive the pose differences? Towards this goal, we design a system, PoseCoach, to help amateur runners analyze and visualize running pose differences in videos. PoseCoach takes as input a user video of the novice and a reference video of an expert, and shows the differences based on the comparisons. The interface of PoseCoach contains 4 views. In the following, we will introduce each view. The pose view shows the preview of 2 temporally synchronized videos and the reconstructed 3D poses in a unified orientation. The profile view shows the profiles of 3 key joints relative to the body center in the 3 transverse planes. The suggestion view contains a timeline of a full running cycle. Pose attributes that are different in the user video and the reference video will be shown on the timeline. The user can preview detailed suggestions of improvements by clicking on each attribute, and the differences will be visualized as 3D animations on a body model for intuition. PoseCoach embeds 10 common pose attributes. Users can customize attributes of interest using the query editor. For example, to label the foot landing position, the user first selects distance, and then pick the foot and body center with mouse on the body model. Landing position is along the y-axis, the user thus chooses the component along this direction. Then the user selects the timing for foot landing. To label the elbow angle, the user first selects angle, and then picks the 3 endpoints in order. To label left foot contact time, the user moves both cursors to select the time range in which the left foot contacts the ground. Now we demonstrate the workflow of PoseCoach with a usage scenario. Suppose Jane would like to check her running form in training for a marathon. She takes a video recording of her running process and loads the video into PoseCoach. Then she also loads the reference video of a professional runner. The overview of pose attributes with large differences is shown on the timeline, so that Jane can navigate through them to see the suggestions of how she can adjust to the professional runner's poses. However, Jane would like to check her knee angle, which is not an embedded attribute in PoseCoach. Thus she labels this angle via the query editor. Now she can preview the difference in her knee angle from that of the professional runner. In the following part, we demonstrate the 3 sessions in our comparative user study. In session PoseCoach without, the suggestive viewpoint is disabled. The participants manually adjusted the viewpoint to preview the pose differences. In session PoseCoach, the participants explore the pose differences with the suggestive viewpoints. In session baseline, the participants explored the pose differences from side-by-side or overlaid synchronized poses. Our user study showed that on average, using PoseCoach with suggestive viewpoint took the least time to identify pose differences from videos. All the participants agreed or strongly agreed that demonstration with 3D animation is more effective in showing pose differences than side-by-side or overlaid. Thank you for watching.